welcome back. I've been working on the generator for the little steam engine turbine thing. What do you want to call it? Rotary steam engine. These are the test pieces for sizes. The copper wire will go in through this thing. That's the outer container. And that was bearing size, shaft size, and the magnet ring holder locations. In Tinkercad I used the array mechanism to set up all these, and I set the little square on the array to like 10, and that's way bigger than 10 for some reason. I must have accidentally scaled it and not seen it on that print, but on the next version it does that. And it also did it to me on the end pieces of the outer casing. I got the bearing in, that's nice and tight. I set these to 7mm and they're like 10mm, so I had to make up these little spaces, which turned out better because I could locate it into the housing. I made the Serpentine coil a bit too long, but I can push those sections in, and there's plenty of room, and I have enough copper to put in another 2 coils to make it 3-phase if I want. So I just gotta glue them on the face here, nice and parallel. It's 0.2mm copper wire. There's 330 turns in there. I did it by weight. I had my little rig set up. I used my thumb as the spacer on the end of this piece and did the wire measurement like that. So on the next one I can fit it in smaller. That way it will tuck in under there, and then on the next one as well, same size, so smaller. So I can definitely fit 3 of those in there if it will turn it. The generator is like tiny compared to the engine. So don't know if it will turn it. It may. If not, I'll have a hand crank generator for it. And that goes on the end. I got the shaft. The bearings go up against that face, the edge on both sides. I made the shaft slightly longer so the steam doesn't interfere. This will attach to the steam engine part. Check out that magnet. The magnets are down there, strong enough to actually hold that on there. They're I could only afford the 40s by 4 by 10 magnets, but I got 30 of them just as well because 2 came broken. Look, what a shame. Shipping. So I've got 2 end caps. This little piece here, that little flange, probably a mistake doing that. That pushes up against this face here on both sides and locks it in so it doesn't wobble up and down. One should stop it if it shouldn't catch. The tolerances is 1mm between the outer, the magnet ring, and the copper thing. I could have shrunk it down to a 0.5, but I wasn't sure how round was gonna print and stuff. I haven't glued the shaft in yet. It's pretty tight. I might not yet, just in case I have to pull it out of there and change some modifications. I've got a little flange on the end to seat it at the right distance through the hole. See that flanged bit? So I'm gonna glue in the magnets today and glue in the coil, first coil anyway, and spin it up by hand, see how it goes. These are going to be very delicate, so I might snip them back and put some thicker leads and solder them up, so we're not having this hanging out the case. Those wires are just going to hang out the back of this. To tell you the truth, I forgot to put some little holes in the casing to put the wires through. I could drill a hole if I need to, but I figured why not just drop them out the back there. It's a prototype anyway. Thing may not even work. Yeah, making the Serpentine coil was a bit tricky. It was Robert Murray Smith makes it look really easy. It's my first Serpentine coil, so yeah. I wish I didn't make it so long now, but too late. I can't cut it, and unrolling it is bad. And strange thing is, I was so that looks like it's wound on there pretty tight, right? So as I was going around, it started unspooling at the opposite end from somehow it came loose like through here and popped up over the edge. And then I kept going, and then I finally got to the bird's nest of wires. I had to unravel it. It took like, I don't know, a good half an hour to unravel that because I just scrunched them up and taped it there until I got to that point of wire. Yeah, unforeseen weird things always go on. So I'll assemble this and get back. Yeah, got 12 magnets in the rotor. I just super glued them. I could erudite them, but I might want to salvage them sometime, so that'll be good enough for now. It's only a test one, so if we want to make it more robust, I'm gonna erudite them in. Okay, the coil's tucked down really well, both ends. The blue lead, for reference, is the start. There's a blue lead inside there. Is the start of the coil. That's for reference for later when I go to put in the other two coils. Then I can, depending on what way I want to set it up, tail to tail or tail heads, or tail to start. Testing the generator, 780 RPM. We're getting 39 to 40 milliamp out of it. And for voltage, we're getting 4.5 volts. It's rectified as well, it's DC, and that's a pretty heavy rectifier. Oh, and if I get that off of there, alright, now we're getting 8 volts, it was actually shorting out. So I might do milliamps again. Alright, we're at 40 milliamps. And we can do frequency test. Hertz. 154 hertz. We could crank it up. Let's disconnect. 870 RPM, we're at 10 volts. Let's see if we got an increase in milliamps. Oh yeah, we're increasing our milliamps slightly. And what frequency do we have? And we're at 176 hertz. Alright, 954 RPM, 192 hertz. 51 milliamps. And DC voltage after rectifying 11. Alright, 6 RPM, 7 volts. So it's working. Not the most powerful generator in the world for the size of it. And only at 372 RPM. Alright, 4 volts rectified. I'm not sure what the diodes in this one will be drawing in load. It was just in my scrap pile. And that's just one coil. We could stick two more coils in there. I think there's enough room. I have some copper over here. Yeah, so yeah, it's okay. I would like to power a house with it, but yeah, you can't do that. There's nothing like that going on in there. I could try doubling the magnets up there by making a new rotor with a deeper trench where the magnets sit. I do have enough magnets, so we could increase that because they're a lot more powerful with doubled up. I've noticed their field push is about an inch compared to the half, so yeah, it gains double. Just you can actually feel the force when pushing the magnets together when there's 2 of them on it. So I could look at doing that. Might just make another coil or 2. I think I can fit 2 in there. It's going to be a bit crowded in here. That's okay. I think it will still squish down all right in there. Plenty of room inside the little outer housing for the coils to sit. It's just the caps are the issue. I'll think about it. Okay, back today. I put the other 2 coils in. I just connected them start to end in there and just ran 2 leads out. So yesterday for 780 RPM, got 40 milliamps and 8 volts. We're at 798 RPM, but it goes down to 70 if I touch it. It's not going to go to 80. So we got 40 volts at 790 RPM today, and milliamps. Okay, for milliamps, we're still at 40 milliamps at the same, which is odd. And frequency, I said that's changed, didn't it? $160 or 154 megahertz on hertz. And if we crank it up to 870 RPM, 876, we're at 176, same frequency. Milliamps. 43, we were 47, we had more. Bit odd. 44. Wonder what's going on there. And voltage. 7 compared to 10. So we've almost tripled our voltage, but we're still getting the same amperage, maybe due to the wire size. And we crank it up to 1170, about 36 volts. And 58 amps. And frequency should be up near 200. Yep, 234 hertz. Can we go higher? RPM, at 288 hertz. $70 milliamps. And voltage, maybe 40. Oh, 45 volts. Alright, winding it down, it's a bit unstable just hanging out there on a threaded bar. Okay, so we're at 480 RPM. We're getting 14 volts, sorry. It's probably worth putting in the extra coil. I made the coils about that much smaller, and it just fitted in there. And when I was disconnecting the original coil from the blue lead, the bloody wire snapped off. I just had like 10 millimeters just left hanging out before I would have had to pull the coil out and fed out some more wire somehow. Whew, got lucky there. So the real thin wire is just too delicate. We could probably go up to 0.2 wire in there. So it was a bit of a squeeze to get it all in there, but it fitted. The little fins I had in there to hold the stator thing, I took them out because they were going to interfere with the coils. I just snapped them off. They were just 1 millimeter thick. Don't need it because the coil's actually pushing on the outer case and holding it all from moving anywhere in there. I'll just disconnect and put it on the bench. Right, and it was rectified still. Okay, just turning it by hand, I can get up to 10 volts. On a good spin. It has 1,020 meters of wire. It was each coil was 340 meters. That's a lot of copper. So you can see it was squishy, didn't you? A little bit, but it did fit. You can actually feel the back EMF now in the thing. Before it would just spin and you couldn't feel any resistance, but you can actually feel resistance in it. We should check resistance. Resistance is 500 and, oh no, hang on. 56 mega ohms of resistance in the copper wire. Oh, hang on. That's gonna not really tell us. So let's disconnect the leads. That's actually going through the rectifier. Connect that one. that one. Alright, there we go. I thought I checked it before and it was like 500 ohms. 553.1 ohms for the thing. Well, so it's not going to power your house or anything, but it's got a little thin wire. I'm thinking maybe 0.2 wire. No, hang on, what was this wire? Where did it say that to? I thought it was written on there. I swear it was the other day. It's very odd. I reckon it's 0.2, or is it 0.02? Here it is. Where's my verniers when I want them? So going by these, which aren't that accurate, because we got, try that. Point 1 it says, but it's probably 0.2. Depends. Yeah, so it was supposed to be 0.2. I was measuring 0.1 minus that much. The thing about these digital ones, you move them and put it back, you get a discrepancy. Yep, well, whatever. Yeah, so it was 0.2, so we'd probably want to go to like something like 0.5 maybe, or 0.4. Very tiny. So that's the generator made. I don't know if the this thing will have enough torque to turn it. But we can turn it into a hand crank generator maybe. And get a few voltage on AC. Get 10 volts AC. 11. Yeah, that's it. That's as fast as I can spin it by hand. 11 volts AC. Alright, well, that's my day completed for today. I have to make up a little stand, something to hold this. And attach it to this. I've got a, that's the part what mounts onto the steam engine, or rotary steam engine. And this attaches here. Should hold it up. And also, I machined in the little steam valve, attachment, so I can attach the copper pipe to the back of this. This goes on there, that will go on there. Compression coupling. I think the compression coupling will work on a piece of solid brass. I'm not sure. Hopefully. Should tighten up and lock in. Alright, that's it for that one. Thanks for watching. Hey, back. I thought I'd test it with the compressed air. Alright, we're on the voltage setting. If I can get it to spin. Yeah, gotta be careful about that. Maybe I should tighten that up. Alright, try again. Hold it a bit tighter this time. Now I forgot what voltage it got to. I think it was 8. That's about. Here we go. Hang on, what's going on? That's too high a voltage. Or was it millivolts? Hang on, check it out again. Wait for it to build up there. Okay, we're at full volume. So it must be doing some RPM to get that much voltage. That's 90 psi. Let it charge up. Okay, trying milliamps now. Wow, hang on. The rubber thing's falling off. That was like 40 something milliamps. Bit hard doing it manually, but it does sort of work. I think the bolt's tightened up on it slightly. Might have to loosen it off, these bolts here, from hanging onto it and letting it bounce around. I do have the thrust bearing in there. I might back these off slightly because it feels a bit tight. Rightio, I backed the bolts off slightly. It's on the milliamp setting. Wait for that to build up. Alright, let's try that again. Keeps unwinding if you hold that thing. Gotta hold those whole bolts. I should put it in an assembly. The little rubber thing keeps riding down the nozzle. Alright, it is milliamp. 50 something milliamps. That's not too bad. But will the steam do it? I got 7 milliamps just spinning that up. I'm gonna have to somehow get oil into there and lubricate it. Might need a little siphoning oil thing attached to the inlet of the steam. Yeah, I think the bolts keep tightening up, holding them. Not quite enough, is it? Needs to come up into there. I'll have to go that way with it and attach that to the something. Put that in there. And bolt this to a bit of wood and this. Well, there you go. So we tested it with some air. I think it was on 90 psi though. Steam might have a bit more bang than the air. I'm surprised it moved it. I weighed the motor. The total assembly is 300 grams. And this is 660 grams. Alright, thanks for watching. I'll post this video today. Hey, I've got it mounted. It took forever to get that to spin like this. Most of my problems was this grub screw thing in here was sliding forward and also pivoting. And it would make this jam up. Once I got rid of that, it sort of just needed a few packers here, and that's it. I think I got it. There's a slight wobble. Oh, I've got this loose though. I reckon there's a bit of misalignment in there. So I might have to leave the generator there loose, sort of, so it can wobble. I'll try tightening it up right now and see what happens. Right, so you hold the roll on there. So it's like almost half a mil there. I think it's the hole patterns in that one because I made that one first, so I didn't line them up properly. And that's about 1 millimeter up. I might be able to elongate these holes here and just get that fine adjustment sometime. To get that out, or I need a flexible coupling. Because they're pretty tight, because there's about not even probably 1 millimeter in between the hole and the outer edge of this. Should have made that larger, and then I could have elongated and made it much easier. So I'll set it up and we'll give it a test spin. Ready for a test spin. We're on voltage. Hang on, what are we not connected? Mechanical issues. I'll just check everything. Oh, these wires here were touching. Oh, get my finger out of the way. These two wires are hanging out. This is up there. I've got it on like so it can go up to 100 volts. Because when I tested it, this started wobbling off, so I put some more tape on it and it exceeded the voltage. Have a watch. How odd. Milliamps. rectified as well. Wowzers. We'll check that hertz. Must be up near 500 hertz. No, I'm gonna have to change the leads over, so sure, let's see DC hertz, if that is a thing. Yeah, that's a thing. Ah, hang on, put it on the hertz. That's just crazy. Little generator's got a little bit in it. So even at half throttle, it's 43 volts there, DC. You probably only want to run it like that. We'll try milliamps at that speed. Come on. Compressor's starting to run out of there, but it's 34. Oh, there you go. I'm surprised that actually went to 100 and something volts. Wowzers. Imagine what it's going to do on some steam. I'll try to rectify this issue so it runs truer by then. I'll definitely be posting now because I'm all worn out from setting all this thing up. But that was worth doing.